Good morning, everyone. Thanks for joining this morning. The webinar this morning is using an Ethernet barcode reader with Horner OCS. So we'll go straight into it, and if you have any questions, we can get to those at the end.
Hello and welcome to today's webinar. Today we're going to be looking at using Ethernet barcode reader with Horner OCS. Let's get started. Let's look at our agenda for today. We'll look at why we use Ethernet for barcode scanning, and we'll apply a Datalogic product with the Horner OCS using Modbus TCP. That's the protocol we're going to be using today. There'll be demonstrations throughout, and we'll finish with a Q&A session. We'll start with the topic of Ethernet for barcode reading. Traditionally, barcode readers have been connected through serial interfaces like RS-232 or USB. While serial barcode readers can work well for low speed and simple applications with limited speed and distance requirements, they do have significant limitations. Serial connections are point-to-point, making it challenging to scale up when adding more barcode readers. This would require additional serial or USB ports, making scalability difficult. Additionally, serial connections have limited bandwidth, often resulting in only receiving the barcode data without any additional information. When using an Ethernet-based barcode scanner, you have the advantage of obtaining additional information along with the barcode data you need. Ethernet allows for sophisticated configuration, access to barcode scan history, live image data viewing, and in some cases, data storage. Another significant advantage is the ease of scaling your system by adding more barcode readers. Ethernet supports the seamless addition of multiple devices because of its ability to handle higher bandwidth suitable for multiple readers. For the remainder of the program, we'll focus on the integration process of connecting the Matrix 320 barcode reader to the Horner OCS over Ethernet. This integration is particularly useful for applications involving barcode scanning and material handling or similar scenarios. Today, we will utilize Modbus TCP as the industrial network of choice to interface between Horner OCS and the Matrix 320. Modbus is a widely adopted industrial Ethernet network used by multiple manufacturers, making it an excellent option for equipment communication across different brands. When working with Modbus and barcodes, there are a few things to consider. Modbus is an integer-based protocol, while barcode data is typically byte-based, character-based, or ASCII-based. It is important to handle the byte order correctly when writing the data. Datalogic ensures proper data writing to the OCS, but when handling the data, it is crucial to maintain the correct byte order. The Datalogic Matrix 320 will act as the Modbus TCP client, while the Horner OCS will serve as the Modbus TCP server. This arrangement allows Datalogic to handle the reading, writing, and polling in the communication process. As the Modbus TCP client, the Datalogic unit will read specific OCS bits, particularly a single bit that signals the start of the reading phase. This bit can be activated by the OCS internally and detected by the Datalogic device, triggered by events like a photosensor activation. This informs the barcode reader to initiate scanning and prepare for barcode reading. Once the barcode is successfully read, the Datalogic device will write the barcode data into the OCS's internal memory space and set a good read bit to indicate a successful read. On the other hand, the Horner OCS, acting as the Modbus TCP server, will continuously monitor the good read bit written by the barcode scanner. This allows the OCS to identify the presence of new data. As part of the processing, the OCS will convert the integer data written by Datalogic into byte array format to handle it as ASCII data. This summarizes the fundamental operations taking place in this configuration. We'll begin by discussing the required configuration for setting up Modbus in the scanner itself, especially in the Matrix 320. We will focus on getting Modbus to work on the Matrix 320. Once we've addressed Modbus, we will shift our attention to the OCS side of things. To set up Modbus on the Matrix 320, we utilize the DL code software, but before we continue, there is one essential step. When working with any of the available field buses on the 320, it's crucial to ensure that the user level in the software is set to expert. Without this setting, we won't have access to the field bus setup options. So make sure to set the user level to expert directly within the software. Next, we need to establish effective communication with the 320 over Ethernet, which is the most recommended approach. In the software, you will find it listed in the left-hand pane. Simply double-click on your scanner to select it and then click on Open Device Configuration to enter the configuration mode. Once in configuration mode, you will see a menu at the top displaying options numbered 1, 2 and 3 from left to right. Then we select the reading phase option. Once you are in expert mode, click on the field bus icon present to add a new field bus. When you press that button, select the option to add a Modbus client, as that is the specific field bus we will be working with today. Once you've added Modbus client as a field bus, click on the Modbus client, and on the far right hand side you will see all the Modbus parameters that need to be configured for Modbus TCP to work. We'll begin with the key parameters that require changes, starting with the start register. By default, the barcode scanner writes the barcode data to Modbus holding registers 40001 and onward. If you set the start register to 0, it represents an offset of 0, meaning the barcode data will be written directly into Modbus holding register 40001. However, using this default offset of 0 may lead to conflicts with other data, such as analog output or high-speed counter data. In our demonstration, we use a start register of 99, which gives an offset of 99. This means the barcode data will appear starting at %AQ1, avoiding any potential conflicts. The number of registers correspond to the number of integer or character data you wish to receive. In our example, we set it to 30 registers, equivalent to 60 bytes or 60 characters of information. Next, we need to configure the remote address of the Modbus TCP server, which in this case is the OCS. We set it to the address of the OCS. Also, we need to configure a connection retry time in milliseconds. We set this to 3 seconds, which worked well. You can likely set it even shorter if desired. These are the basic Modbus TCP parameters for the 320. Now we need to perform some I/O mapping, starting with the phase on setting. In the center pane, select phase on and click the corresponding button. On the right hand pane, you will see various options that can trigger the read phase. Choose one of the Modbus bits to activate the scanner's read phase. In this case, we select the first bit. The bits on the screen, 0 to 7, correspond to %die 1 to 18. Once you've chosen the desired bit to initiate the read phase, you need to specify the action. The leading edge of that bit should trigger the read phase to turn on. To deactivate the read phase, click on the phase off button and once again select the same bit that we used to activate it. However, this time, choose the trailing edge option. When that input bit turns off, the read phase will be deactivated. Another useful feature is to automatically turn off the read phase upon a successful scan. To enable this, you turn it on by activating the input bit. As soon as the scan is complete, it will automatically deactivate the read phase and exit the read mode. There's still some remaining work to be done. We've configured the input side, which activates the scanner's read phase. Now we need to configure the output bits that the scanner writes to the OCS to indicate status. The two basic ones are good read and no read. We'll begin with good read. In the center pane, click on the Output Setup tab at the top and then select the Good Read button. We can map that to a specific Modbus bit, which will be an output bit. These output bits will be mapped to %Q1 to 8, so 0 to 7 on the screen corresponds to Q1 to Q8. In this example, we chose the 7th bit to indicate a good read. It turns on whenever a good read happens and is written or activated. Additionally, we configured it to automatically turn off after a timeout of 1 second. And then similarly for no read, we also need to configure a different output and again correlating somewhere between Q1 and Q8. And we'll configure it to turn off after a second also. When we're done with that step, the last step is configuring the output and configuring the reader. At that point, we can save our file to the device and we can exit the software and things will start running. The Horner OCS is acting as the server, so there's a lot less to configure. You basically go into the hardware configuration, you click on the Ethernet port that is going to be acting as the Modbus TCP server. Once you've selected the Ethernet port, you need to make sure that your Ethernet addresses are set up like they normally would be. IP address, net mask, etc. Once you've done that, all you have to do is check the checkbox for Modbus server and you're done in 99.9% of the cases. There are some additional parameters you could change if you wanted to, but it's going to be used very rarely. So at runtime, the OCS is going to turn on the digital input bit that is being read by the 320. That's going to tell the 320 to go into read phase. Once that happens, the 320 is going to read the barcode, write the barcode data to the AQ registers that are again mapped over Modbus. And once that's done, it's going to send a good read signal and write that to the %q that's mapped over Modbus as well. And then after a second, the good read bit's going to turn off. Now we'll examine data handling in the OCS. The barcode data, represented as byte data, is written over Modbus, which uses integer type data. Each integer occupies 2 bytes equating to the Modbus specification. The OCS stores this data as integers. In register-based advanced ladder programming, you don't need to worry about the byte order, as the OCS automatically handles it when using the ASCII function on integer data. However, if you're using a variable-based language like variable-based advanced ladder or IEC, you'll need to unpack the integer data into a byte array and ensure correct byte handling. We have a ready-to-use example program available for download that handles this process. Whether you're using a barcode scanner like the Datalogic, which writes data in the correct order, or another device that requires byte swapping, you'll have the necessary tools to arrange the bytes correctly. Now we'll have our demonstration using the Datalogic Matrix 320 Ethernet barcode reader. We'll start in Cscape, then move to the bench, and then return to Cscape. The setup process has been straightforward. From Cscape, we'll quickly configure the Modbus settings. In the I/O configuration, select the LAN port for Modbus TCP server and ensure the IP addresses are correctly set up and that Modbus slave is configured. So on the OCS side, that's all that needs to be set up. We've also performed some mapping using variable-based advanced ladder programming, so we'll look at that now. The barcode data is written starting at AQ100 with a capacity of 30 words or 60 characters. So AQ100 to 129 is where the barcode data is coming in. We've mapped this data to a variable called barcode integer. The good read signal is written by the 320 to Q7 through its Modbus map, while the bad read is received via Q8, and both are mapped to internal variables. This covers the basic OCS configuration. We'll explore unpacking the integer data into byte data shortly. Now we'll look at the bench. Here we have the Datalogic Matrix 320. It features a convenient built-in express user interface consisting of a single button and a series of LEDs. This interface allows for quick aiming and focusing without the need to bring your computer to the production floor. Mechanically, the device is robust, with mounting holes at the back for easy bracket installation. It offers various connectors, including a multi-connector for I/O and serial port connections, as well as an industrial Ethernet connector. In our setup, both the 320 and the XL7 are connected to an Ethernet switch. For demonstration purposes, the read phase bit mapped to I1 is controlled by a switch on the I/O simulator. When the switch is flipped, I1 is activated, initiating the read phase. Indicators for successful and failed reads are provided by the barcode reader itself. The read data will be displayed on the screen. Now we'll perform a quick read. We activate the read mode and aim the device towards the barcode. The indicator turns green upon successful scanning and the number is displayed temporarily. Repeat the process for another read by cycling the read phase button or input. If a barcode cannot be read during the read phase, a failed read indication will be shown. This covers the runtime operation, which is quite straightforward. Now we'll return to Cscape and discuss unpacking the integer data as bytes. If you're using register-based advanced ladder programming, there's no additional action required. The barcode data written as integers by the Datalogic Matrix 320 is already in the correct byte order, and the ASCII functions will handle the unpacking properly. However, if you prefer utilizing the advanced features of variable-based advanced ladder programming, There's some extra work involved to reap the benefits. So we'll firstly look at byte order. Now, if you're using most Modbus barcode scanners, the integer data is going to be written in the proper byte order. But even if it's not, you can change this contact in the sample program to always off, and it'll handle reversing the bytes. But if you're using a Datalogic, you can just leave this as an always on because it writes the data in the normal fashion. So every time we get a good reading, we'll turn on a one shot, and then we're going to go through a loop, and we'll unpack the integer data that was written by the barcode reader, and we'll copy it into a byte array. In the variable list, barcode integer represents the incoming data, while barcode byte is where the unpacked data is stored. To handle the mixture of word and byte functions, a trick is used, involving a word variable mapped to a specific memory location and a 2-byte byte variable mapped to the same location. This allows for individual byte manipulation while representing the same data in words and bytes. After unpacking the bytes and placing the information in the byte array, the logic handles displaying the barcode read results on the screen and removing it after 5 seconds. Unpacking the bytes requires some extra effort, but remember that if you're using register-based advanced ladder, this step isn't necessary. So what are the advantages of Ethernet barcode readers? Adding multiple readers is much easier with increased bandwidth as it handles them without issues. Configuration and runtime offer additional tools such as live and stored image viewing thanks to Ethernet accessibility. The OCS primarily deals with barcode information while the data is available for external access via a web browser on the network. Specifically, we discussed the Datalogic Matrix 220, which offers flexible Ethernet options including Modbus TCP, Ethernet IP, and various other protocols. So that concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Sending SMS, using an email to SMS service, and the registration is up for that. Let's have another quick look for any questions in. Nothing currently. Okay. Other than that, thank you all for joining this morning, and we'll see you again next week.